These notes are for integrated 1. These are our percent multipliers notes. So a percent multiplier, basically, which is kind of what we've been doing with our common ratio, is when we talk specifically about something increasing or decreasing by a percent. So if we take a look at our percent multiplier here, this is when we want to try to figure out a percent increase or decrease. All right, so they allow us to calculate very quickly with one single multiplication. All right, let's take a look at the two different types. We have a multiplier increase. We're going to add the percent increase to 100. So we're always going to start with 100%. If it is an increase, we're going to add it to 100%. Then we're going to convert the new percent into a decimal. So hypothetically speaking, let's say we have a 5% increase. So it's an increase from 100%. So we're going to do 100% plus the increase 5%, and that's going to give us 105%. Now, as a reminder, whenever we turn a percent into a decimal, we want to find where the decimal point is. Now, if we take a look at 105%, and I don't see a decimal, the decimal's always hiding behind the last number. So this is actually 105.00000%. So what we're going to do is we're going to grab that decimal point and we're going to slide it 2 spots to the left. So as a multiplier, this is going to be 1.05. It's no longer a percent. This is actually our percent multiplier. So here's our multiplier. Now, let's take a look at the next kind. Well, the next kind is if we have a multiplier decrease. We're going to subtract the percent decrease from 100%. So we're always going to start with 100%. Then convert the new percent into a decimal. So same process, except if it is a decrease, so let's say we have a 4% decrease, we're going to start at 100% and we're going to decrease that by 4%. So that's going to give us 96%. And then remember with the decimal point, if you can't see it, it's hiding behind the last one. We're going to slide it 2 to the left. So this is going to give us 0.96. That's our multiplier. Now, important to note, so let's put this off to the side back in the names. If you have a multiplier increase, this decimal is bigger than 1. So let's say it's greater than 1.00. If you have a multiplier decrease, then we're going to say this decimal is in between 0 and 1. So really, if it's a multiplier decrease, it's going to be smaller than 100%, but it's got to be bigger than 0%. And if it's a multiplier increase, it's going to be bigger than 100% because we added something to 100. All right, let's take a look at these examples at the bottom. So here we have a decrease. All right, so I'm going to start with 100%, and I am going to decrease it by the percent that was given to me. If I subtract those, it gives me 87%. Find the decimal point, and we're going to move it 2 to the left. So this is going to give us 0.87. All right, the next one, this is an increase. So start with 100%, and we're going to increase by that percent. So that would give me 108.7%. I see the decimal point this time, so I'm just going to slide it from where it currently is. It's going to be 1.087. Okay, we have a 42% decrease. All right, start at 100%, decrease it by 42%. So if we do that, that's going to give us a 58%. All right, find the decimal point. Can't see it, it's hiding behind the last one. We're going to rewrite this as 0.58, and then we'll do the next one. It's an increase, so it's coming up from 100%. Notice that I keep starting with 100%. That's important. Okay, and then grab our decimal point, which I can already see, and let's slide it over 2 spots. Okay, those are my percent multipliers now. I've turned them into decimals. Now let's actually use these on some problems. Okay, so here we've got an example. So Jocelyn invests $400 into an account that earns, okay, looks like she's making money. It earns 3% each year. Earning. All right, let's go ahead and do this now. If she has a 3% increase, that's going to be 100% always, plus, and that's an increase. We're going to add those together. That's going to be 103%. Find that decimal, and let's move it over. So that's going to give me 1.03. Okay, this is my multiplier. All right, let's keep reading the rest of the question. We want to write the explicit equation. All right, let's color code some stuff. So we want to write the explicit equation. And, okay, we've got something else we have to do too. Determine how much money is in her account after 7 years. And we're assuming she's not taking any money out. All right, I think we need to try to write this equation. So if we take a look at this, we have the amount of money that Jocelyn invested. So if I were to set up a table on this, so I would say N and T of N. See if we can convince ourselves about this equation. Now we know that she deposits $400. So this is the very beginning of her account. It hasn't been in the account for any time frame yet. That's what she's starting with. 1 year later. So let's say that this is years. And then T of N, we're going to let represent money. After 1 year, her money has increased by the multiplier of 1.03. So if we were to type that into our calculators, we would get 412. The second year, okay, we would multiply again by 1.03, which gives us 424.36. And then we would keep going in this fashion. All right, I think we can now extract the information here. So let's see. Our multiplier, which we already determined was 1.03, that's going to be B. And then we have our 0th term, so it's her deposit amount. So for our equation, we're going to say T of N is equal to her 0th term, so it's the amount of money she started her account with, which is 400, times the multiplier. And the multiplier gets the exponent, since that's what we keep multiplying by repeatedly. All right, the next thing we need to do is you can either use your table or you can use the equation. We're trying to figure out what happens after 7 years. So we're going to plug 7 in to our equation. And then this is going to be money. So let's do an approximation on this first when we type it in. And then we're going to actually make sure that our decimal makes sense. So when I type this in, I got 491.9495.462. Now, this is money, so it doesn't really make any sense for us to say that's how much money she has. Plus, it's a word problem, so we're going to have to answer this. So Jocelyn will have And then let's think about this realistically. I know that we've been taught to round decimals, but it kind of depends on the perspective. So if she put this money into a bank account and she goes in to withdraw her money, we have to think about this realistically. So let's look at where the decimal should cut off. So right in between the 4 and the 9. Do you think that the bank is going to round up and make it 95 cents or round down and make it 94 cents? It's going to be 94 cents. So the bank is never going to give you more money than you absolutely are entitled to. Unfortunate, but true. So Jocelyn will have $491.94 in her account after 7 years. Okay. We got one more, and then let's see if you can actually set it up. So Liam purchased a car for $25,000. Okay, so I could actually start setting this up. So in the beginning, Liam spent, so in the beginning, he hasn't had it for any time, he spent $25,000 on it. The value of the car depreciates. Okay, so to be clear, folks, depreciate means that it goes down in value. So I should give you an idea of what the multiplier is. So now would be a perfect time for you to pause, see if you can come up with the multiplier on this. Okay, so to get the multiplier, I'm going to start with my 100%. And this is a 9.4% decrease. So I'm going to start with my 100% and I'm going to decrease it by 9.4%. So from here, we'll take our 100 minus 9.4. That's going to give us 90.6%. Remember, grab the decimal. Let's move it over 2 spots. So 0.906. This is our multiplier, which means this is going to be B. So we would multiply by 0.906 to get to the end of the first year. So we're going to take our 25,000 times it by 0.906. That's going to give us 22,650. And we could continue doing this, but if I had to guess, we would probably be required to write the equation. So this is going to give us 25, 20, and 90 cents. Okay, so on and so forth. All right, let's go back to the directions. So how much will his car be worth in 10 years? All right, so let's write the explicit equation here. So T of N started out, so 0th term is the 25,000. And the multiplier is 0.906 for however many years. Well, in this case, we want to find it for 10 years. So we're going to do T of 10, and I'm going to plug a 10 in for this. You'll notice that the multiplier is between 0 and 1, which means the value should be going down. And it did. So from the calculator, we have 9315.839239. All right, well, let's go to where the decimal would actually happen, between the 3 and the 9. And let's see, the value of the car. So how much is this car going to be worth? Probably not going to be rounded up. But honestly, it depends on the situation. If Liam is trying to sell his car, he could actually ask for the 84 cents. But if he's trying to get money from a dealership or a bank, chances are they're going to give him the 83 cents, or that's what they're going to say the value is. So we're going to say Liam's car is worth $9,315.83 10 years later.